Alright folks, I'm going to try to record this in 20 minutes. So, zero force member. First thing we always need to look at for zero force member is always the x and the y axis. Alright? Summation of y should always be 0 and summation of x should always be 0. Using methods of join, you don't need to bother about moments, alright? So we're just going to use these two equations, summation of y, summation of x. Let's go ahead and dive right into the first scenario. And let's make it relatively simple with 2 bar that is running along an axis. Alright, I'm going to use this as my pivotal point. So we have bar A and bar B. Let's first assume the direction of the force that is is either tension or compression. So I'm just going to assume that A is in tension and B is also in tension. So if you look at my orange circle, which is my reference point, essentially is like this, and labeling the forces Bx, Ay. So using this equation summation of y equals to 0, in this case, okay, I'm going to say going up is positive. So in this case is negative Ay equals to 0, and then summation of x equal to 0 as well. Going right side is positive. In this case, my b is going left, so negative bx equals to 0. Now, in this case, I can ignore the 0. I can ignore the negative. Because if I bring over the negative, 0, negative or positive 0 is still 0. So just by looking at my equation, what does this tells me, or what can I conclude? I can conclude that Ay equals to 0, Bx equals to 0, which means that these two are zero force member. Basically, they are not exerting any force at all. Alright? This is based on equation. Right? But then, if I were to look at my diagram, this is how I can also deduce it from the diagram. Following Newton's third law, we should always have an equal and opposite reaction for my free body diagram to remain in equilibrium. Right? Because you always want your FBD to remain in equilibrium. If it's not in equilibrium, your object will be moving. Alright? So if let's say A do have a force, my whole free body diagram will be throwing itself upwards. Right? So in this case, we need to have something opposing it. Alright, but because there is nothing opposing it, you have to assume, or not you have to assume, you know that Ay equal to 0. Because in order for it to not fly away, it does not need to have any force acting on it, or it shouldn't have any force acting on it. So, just by looking at the diagram, you know that bar A is a zero force member, bar B is also a zero force member. This is for case 1. Alright, another example for case 1. Now I am going to draw a slanted bar. Okay, same thing. Reference points, or my pin or my joint is over here. I'm going to label this bar A and bar B. So now I'm going to assume that my A is in tension and my B is also in tension. Same thing, summation of Fy. Oh, my bar B is now slanted though. What does that mean? Let's just make life easier, okay? Let's decompose it. So we know that this is A, Y. How about this? we know that here is bx and here is by. Oh, but just by looking at my joint, it's a bit weird that one look you can tell summation of y, you're gonna have, because both of my forces are going down, they won't really become zero, am I right? So this means that I know for sure if my A is in tension, my B have to be in compression. So what does that mean? That means that my B is now acting this way. So that means that if I were to decompose my B force, it would be like this. To draw it cleaner, honestly it doesn't matter, but I'm just touching on it because I want to also like show you guys the thinking. I don't want you guys to just like always think one direction. It's nice to be open and think flexibly. Right, so in this case we have a by and then we have a ay. This makes sense. My summation of y can now be equilibrium, whereas at the start it was like this, which doesn't make sense. And then just draw the last force, which is bx. Right, let's equate. So coming back to summation of y, going up is positive. So this means that by minus ay equals to 0. Summation of x equals to 0. Right side is positive, so bx equals to 0. Oh, if my bx is 0, anything times 0 is 0. So in this case, my by will be 0. So if I were to take this equation and rewrite it, essentially just ay equals to 0. So in this case, bar A and bar B are also zero force member. And this is still case 1. So a summary of case 1 is basically, as long as one bar is parallel to either x or y, and the other bar, I don't really need to care what is it, and there is no external force. Okay, so just to clean it up, or just to make it very clear and concise for you guys, for case 1, I should only have 2 bars, one of which parallel to either y or x axis. No external force on joint. So if you look at my first example of case 1, my bar was essentially an L shape. And the second example, one of them was slanted. In this case, this is parallel, and just nice, this is also parallel. Alright, which satisfy this condition 2 times. For my second scenario, this is parallel, which still satisfy this condition. Same thing, both of them got 2 bars, and both of them do not have external force on joint. So this is case 1. Now case 2, slightly unique. Okay, I'm going to color these 2 bar different. Okay, I'm going to use different color. So case 2, oh, you might hear my vacuum cleaner coming in. We have bar A, bar B, bar C. Reference point, the joint is over here. Don't mind my vacuum cleaner. Alright, let's assume the forces. A pulling up. So A will be, this will be my AY. In this case, common sense that in order for it to be equilibrium, my C have to be pulling up as well. CY. And then B, doesn't matter, I'm just gonna do BX here. So let's solve. Summation of y equals to 0. So we have cy minus ay equals to 0. So cy equals to ay. Summation of x equals to 0. This side positive. So negative bx equals to 0. And there you have it. Now, can I say that all my bars are zero force member? Well, let's just take a look at the equation. Let's take a look at summation of x first. Over here, my bx equals to 0. And what does this mean? This means that my bar b is a zero force member. How about bar a and c? Well, because cy equals to ay, as long as one of them have a certain force acting on it, either have more than 0 Newton force acting on it, they won't be zero force member. Alright, so in this scenario, which is, if I'm not wrong, case 3, bar B is a zero force member, bar A and C is not a zero force member. Moving on to something a little bit more complicated. Let's slant the bars now, okay? Alright, same thing, reference point over here, A, B, C. Alright, let's draw the forces. This one going here, this one going here, and this one going here. So, I'm going to decompose each one. So it's AY and AX. BY, BX. CX, CY. Drawing the reference point. Okay, so my AY is pulling downwards because equal and opposite. So we have AY and then we have a AX here. And then we have a BX here as well. And then we have a CX here as well. And then we have a BY here as well. And then over here we have a CY. Alright, so let's equate. Summation of y equals to 0, upwards is positive, so we have cy minus ay minus by equals to 0. Summation of x equals to 0, we have cy minus ax minus bx equals to 0. Now let's take a look at bar A and bar C. They are collinear to each other. They are parallel to each other. Keyword, collinear. Okay, so what does this means? Oh shit. This means that if I were to draw a y-axis line over there, these angles are the same, which means that AY equals to CY, which means that A cosine theta equals to C cosine theta. And because these two are the same, cancel, cancel, A equals to C. Rewrite the equation. I'm just going to substitute it. So my C become A. So in this case, it's just AY minus BY equals to 0. Cancel, cancel, BY is equal to 0. AX minus BX equals to 0. Cancel, BX equals to 0. So this is just another example of case 3 where I don't know what color to use, purple or whatever. My A and C, they are members with some force. Okay, as long as one of them have force, the other one will have. Or another case, B will have a force or will not have a force. So B is a zero force member. But that's using equation to find it. Let's not use equation to find it, okay? Let's use something else, okay? Let's just look at the diagram. Oh, I didn't mean change color, whatever. Based on the diagram, I know that this bar will have a x force, and this bar will also have an x force. This bar will have a y force. Okay? My y cannot suddenly become an x. No way. My y force will always have to stay as a y force. And this x suddenly cannot become a y as well. So what does that mean? That means that, okay, let's look at the x force first, okay? Oh, I have two x force opposing each other. Newton's third law, this makes sense. However, my y, I have nothing opposing my y at all. And in order for it to be equilibrium, y have just to be 0. How do I make sure that this will not become a zero force member? Very simple. Add an external force. Voila. That's it. So, case 2, I'm not going to explain it, but I'm going to show you why it is essentially just case 3. Okay? Case 2 is basically like this. Doesn't this look very similar to case 3? Instead of 3 bars, I'm replacing one of my bar with an external force. So, it's basically hiding itself in case 3, because this can be A, B, and C, which is the same example as case 3. Am I right? Angle, everything's the same, so we know that A equals to C, and B just equals to 0. So this is case 2. Case 2 and case 3 is basically the same. Just that for case 2, you get 2 bars, 1 external force. For case 3, you get 3 bars. So to summarize case 2 and 3, you will need to have 3 forces acting on joint. These 3 forces can either be, for case 2, will be 2 bar plus 1 external force, or 3 bars. Then you need 2 forces to be collinear to each other. What else? What else? I think that's it. Yeah. Understand that only 3 forces can be acting on it. The moment there's 4 forces, don't even need to consider whether it can be a zero force member or not. It have to be 3. Die have to be 3. 5, don't even bother. So if your joint, my voice cracked, if your joint look like this, where there's multiple connections, how many forces are there? 1, 2, 3, 4, 5, 6. It doesn't even satisfy the first condition. Screw you, I'm not even going to consider you. You get out of my life. And this is zero force member.